Yes, in addition to the formation of temporary hardness of water by dissolving calcium carbonate or magnesium carbonate in water containing carbon dioxide to give you calcium hydrogen triazocarbonate and magnesium triazocarbonate, hydrogen triazocarbonate, forming temporarily hard water, which can be removed by boiling. Permanently hard water contains magnesium sulfate and calcium sulfate. Calcium sulfate usually form when gypsum dissolve in water. You get calcium sulfate, and you get magnesium sulfate to dissolving in water, because these two compounds are soluble in water. Two other compounds that are soluble in water are calcium chloride and magnesium chloride. So with these four ions, permanently hard water result, and this cannot be removed by boiling. So what are the different ways of removing hardness of water? I'm going to start with temporarily hard water. Now, the first method for removing temporarily hard water is by boiling, and another method we can use is addition of slaked lime. So let's start with boiling. Now, when water containing calcium hydrogen triazocarbonate or magnesium hydrogen triazocarbonate is boiled, now this compound is soluble in water. When it is inside water, the water will still be clear. You will not see any signal, no whitish substance formed. It's just clear. But when you add soap to it, definitely it will form scum, a whitish substance anyway. But the issue is that this compound is like a salt that is soluble in water. When you boil the clear water, it will break down. This compound will break down into calcium triazocarbonate for water and CO2. This compound, don't forget, is not soluble. It's like a white substance, limestone, that is responsible for the formation of scum, or the layers that are found on boilers and kettles. So boiling temporarily hard water results in thawing of kettles and boilers. That's the effect, because of the deposits of calcium triazocarbonate fall. Also, it's also end up forming stalagmites and stalactites. Stalactites are usually formed from the roofs, while stalagmites are formed from the floor. These are strong pillars. These are pillars of calcium triazocarbonate. For how does it happen? Now, when rainwater containing carbon dioxide, don't forget these two forms H2CO3, weak acid. When they pass through the roof of caves, limestone caves containing calcium triazocarbonate 4, which is a limestone, the roof of the cave. So when these three combine, temporarily hard water results. That's calcium hydrogen triazocarbonate. Now, and don't forget that the roof of that inside a cave, the temperature is very, very high. So because of the high temperature, this compound in water is subjected to the high temperature, and so it undergoes temporary boiling or partial boiling to break down again. So calcium carbonate, water, and CO2. Again, rainwater containing carbon dioxide, dissolved carbon dioxide, which is found in the atmosphere. These two combine together to form weak acid, which passes through the roof of limestone caves. These three combine together to form calcium hydrogen triazocarbonate. The same thing occurs in magnesium hydrogen triazocarbonate. Now, because the roof of the cave is hot, because the cave is hot, it breaks down this compound again to calcium triazocarbonate for water and carbon dioxide. And this one is a whitish substance. When it drops on the floor of the cave, it solidifies and forms a whitish substance like a rock, and it continues to pile up for hundreds of years. And some drops on the roof of the cave too. They also pile up there, and before you know it, they begin to grow. Deposits of this calcium carbonate begin to grow towards each other to form what we call a strong pillar. The one coming from the cave, from the roof of the cave, is a stalactite, while the one coming from the floor of the cave is a stalagmite. And that leads us to another method for removing temporarily hard water, and that is the use of slaked lime, calcium hydrogen triazocarbonate, sorry, calcium hydroxide. I'm so sorry for that. Calcium hydroxide. When you add these to water that is temporarily hard, when this is added to water that is temporarily hard, you will end up getting calcium. You know, this is soluble in the water. We want to remove the calcium carbonate because this is soluble in the water. You don't know that the water is hard because of the dissolved calcium hydrogen triazocarbonate. So when we add this, calcium carbonate will be formed. You know, CO3 is in two places here. We have calcium carbonate, which is a whitish substance, to solidify out white, and it is not soluble. And then we still have the remaining compound. Don't forget we have 2 calcium here, so we can use this. And then we have the remaining as water made up of hydrogen and oxygen. So in that case, we have 2 hydrogen making 4 hydrogen, then 2 oxygen. So this is now filtered. When it is filtered out, you get your clean water and soft water. The last method is by using, this is not really common, washing soda. You can use washing soda to remove temporarily hardness of water. This is also applicable to permanent hardness. So this method is used to remove both hardness of water. Number 4 is distillation. Distillation through boiling and distilling the boiled water through a Libby condenser, we can also get soft water because the ions will be left behind. Now, what happens here? What we get is this. We will end up getting calcium carbonate out, which is a white substance, and then sodium hydrogen triazocarbonate. This is what we'll end up getting when we use washing soda. Now, that leads us to permanent hardness of water. I'm going to show this in another video.